Hey, we're gonna learn a little bit more about 5.1a here right now. 5.1a says to use the identities to find the answer, so hopefully you watched that previous video, but this is specifically aimed at questions 7 through 32. So first we'll start with 7. I want to think of a trigonometric identity that lets me use the sine and the cosine to find the other 4 trigonometric functions. The first one that occurs to me is maybe I should use the fact that the tangent is equal to the sine over the cosine. If that's true, then I can put 1/2 over root 3 over 2. So that means that the tangent's equal to 1/2 over root 3 over 2. And if I want to simplify this compound fraction, I can multiply both the numerator and the denominator by 2, which is 2 over 2, which is 1, so it's no big deal. It's not changing what it means. It is changing how it looks, though. Makes it look a lot simpler. It's going to be 1 over root 3, which means that the tangent is equal to root 3 over 3. And to get the other 3 functions, they're all reciprocals of the other 3. So in the case of the cosecant, that's the reciprocal of 1/2, so that equals 2. The secant is the reciprocal of root 3 over 2, because it's the reciprocal of the cosine, so that would be 2 root 3 over 3. And the cotangent's the reciprocal of the tangent. And since the tangent's 1 over root 3, then the cotangent is root 3. So then we got all 4 trig functions from that. And now 21 through 26 and then 27 through 32 go the same way. You got 6 things up here that are equal to one of these 6 things here. So I know you can use the process of elimination to figure out 1 or 2 of the answers, but that's not what I want you to do. I want you to use algebra. And so that means you're going to be using trigonometric identities to figure this out. Okay. First one says 21 is secant of x times a cosine. Well, the secant is 1 over the cosine, which means that they're reciprocal functions, cosine and the secant. So when I multiply them together, I get cosine over cosine, which is 1, which means that 21 is D. So we know that that answer is D. And notice that I never write equals, and I'm never writing to the left. Writing to the right, I'm moving down. That's the way you should show these identities simplified. Okay, so the next odd one is the cotangent squared minus the cosecant squared. If you look back on page 350, it's always a good idea to read the section before you start doing the exercises. But there's a reference page there on 350. It has all the identities, and the one I'm going to make use of now is the third Pythagorean identity, which says that 1 plus the cotangent squared is equal to the cosecant squared. So what I'm going to do now is I'm not going to change the cotangent. I'm going to leave it the way it is. I'm going to change the cosecant squared x for what it's equal to, which is 1 plus the cotangent squared x. Now, if I distribute that parentheses, that negative on the outside, I get -1 and negative cotangent. And then lo and behold, the negative cotangent squared cancels. With the cotangent squared, and we have what's left is -1. So the answer is -1, which is answer B. Okay, and then also on page 350, there's a section called the even and odd identities, and that has to do with the fact that for an even function, the f of the opposite of x is equal to the f of x. And an odd function, the f of the opposite of x is equal to the opposite of the f of x. So what's that got to do with this? Well, I know that the sine is an odd function. It's an odd function, you can tell because when you look at the graph, it looks like it's been reflected across the origin. So that means that the sine of the opposite of x is equal to the opposite of the sine of x. And now I'm going to put that over. See, the cosine of the opposite of the x is an even function, which means that the cosine of the opposite of x is equal to the cosine of x. And now this is the tangent. So that means the answer is it's the opposite of the tangent of x, which is which one up here? E. So that's how you do that. Now you get to do the even ones on that section on your own, and then you can do the same thing for 27 through 32.